Hi. In this video, we're going to be discussing bias in word embeddings. It's a really important topic, and that's also why this topic will be discussed in not one, but a couple of videos. In this video though, I would like to focus on one way of measuring bias in word embeddings. So let's remind ourselves of what word embeddings are. The idea behind a word embedding is that I could have some sort of word, let's say cat, and this is going to be represented by a numerical array. And typically, the way you get these numeric arrays is you have an algorithm that looks at how words are being used in sentences, and then all sorts of numeric tricks are applied, and you typically end up with a clustering of sorts. So you can imagine that cat and dog are relatively similar words, and that therefore their numeric representation is somewhat similar. Given that we have a pre-trained word embedding then, we can start thinking about the relationship between words. The idea here being, if I have a two-dimensional word embedding, let's say, and I have cat over here and I have dog over here, then the word embeddings themselves can be interpreted like these vectors over here, but we might also ask ourselves the question, well, what does this mean then? This vector from cat to dog. And it's this phenomenon that I would like to zoom in on in this video. So what I'll do now is just come up with a couple of examples of these embeddings. So I could have he and she over here. And maybe someplace else I have cat and I have dog. Now the interesting idea here is that it seems very plausible that this direction that we have over here, from he to she, that direction's probably going to be really different than from cat to dog. This sounds plausible both from a linguistic sense, but also from an algorithmic one. The way that the word he is used in language and the word that she is used in language is substantially different from how the word cat and how the word dog are used in language. So it would be somewhat coincidental if the direction of these two arrows in word embedding space would be the same. What you might expect, though, is that if you have, let's say, two other words that are also very much associated with gender, something like him and her, well, then in this case, you can say, well, maybe the direction's not 100% exactly the same, but it is somewhat more plausible that this direction, from he to she and from him to her, there's something to be said that maybe that general direction, maybe this direction represents gender. That's a hypothesis that you might have. So let's just quickly verify if this is true. If indeed the he, she, him, her direction is different than the cat-dog one. Because if that's the case, that will be interesting. And we can verify this using the what lies package. So what I've got here is a Jupyter notebook. I've imported what lies, and I'm about to do some exploration using the English fast text language. And what I can do with this code is get the embedding for the word he. And this embedding is just an object. Inside of it is a numeric vector. But it's slightly easier to reason with these objects as opposed to just these vectors, because what I can just do is I can say, well, I want to have the embedding for he minus she. And I can do the same thing for him and her. And let's also do that for cat and dog. And what I can do with an embedding is I can say, well, calculate the distance from this embedding to another one. And the base distance measure that I'm using here is cosine distance. And what we can see here is that the distance from embedding 1 and 2 is not too big. So just as a reminder, what the cosine distance measures, if you have two vectors, is the cosine distance doesn't measure this distance over here. It doesn't measure how far the arrowheads are apart. Instead, what it calculates is this angle between the two vectors. And considering we're interested in gender direction hypothesis, which is more about the angle, I would argue that this cosine measurement for the angle is indeed the thing that we're interested in. If I were to do the same thing from 1 to 3 though, it is a lot bigger. So these numbers are nice, but I think it's going to be more informative to make a proper plot. So what I'm going to do is I'm going to put these embeddings into a embedding set, and that allows me to just say, hey, I want to plot the distance. And let's use the cosine distance as my main metric. And this gives us this distance matrix, which is just slightly easier to reason about. Over here, we see that there is indeed some sort of overlap. We can see from the color green over here that him and her are indeed somewhat similar to he and she. And we can see that cat and dog is really not similar with he and she, etc. So what we see here is that there might be something to this idea of a gender direction. There is correlation, I suppose you could say. And that means that we can start thinking about what lies on this gender direction. What things should correlate and what things should not correlate with it. So if I start thinking about some other words that might also correlate with this direction, so to say, I mean, man, woman would be a candidate. But now that I think of it, there might also be some other things on this axis that might also correlate. What about stereotypes? If I start thinking about maybe stereotypical male jobs and stereotypical female jobs, well then it might be plausible, albeit highly unfortunate, that we might get that doctor is perhaps more of a male term, and that maybe nurse is more of a female term. It is of course completely ridiculous. Doctors can be male or female. Gender doesn't determine what job title you have here. However, I can imagine that in a lot of texts that a lot of these algorithms might be trained on, there might be a bias in the language. If you go to pages like Wikipedia, historically, men have gotten more opportunities than women. So it shouldn't be too surprising that scientists and doctors have often been male professions. So it can be the case that these sorts of correlations will pop up in our language models. If there's bias like this in the pre-trained word embedding, that's a reason for concern. You're going to have to be careful with applications. You don't want to have a job application algorithm that is favoring men for certain roles and women on other roles. Not only would that be highly unethical, it would even be illegal in a lot of countries. But we do have this phenomenon, perhaps, in our language models, where the algorithm is biased towards thinking this way. So let's check if this property can be measured. And what we can do is we can check if this holds for fast text and many other language backends. So just empirically, can we verify that indeed we also have this gender correlation for certain job titles? So the idea is to get ourselves a chart that's like this one, but now for job titles. And I've written the code that does that. And what I'm going to do is I'm going to have a look at all of these word pairs. So what I've done is I've made pairs and I have them in 3 separate categories. I have my stereotype pairs. These are all jobs that I think might be biased in the language and might have a stereotype on the gender axis. And I'm interested in seeing if they at all correlate with these, what I would argue might be appropriate pairs of words. In these words, I can argue that gender indeed contributes to the meaning of the word. And what I've also done is I've added some random pairs because these shouldn't correlate with either, and that way in our chart we should be able to remove some spurious correlation visually at least. So what I've done is I've written the code down below here that makes this chart, but the interesting thing is the distance chart itself. So what I'll just do now is just zoom in on that. So what do we see? Well, we see some sort of clustering appear. It seems that physicians and nurses and doctors, they're all somewhat similar. We also see some sort of clustering appear when it comes to man, woman, brother, sister, father. And I would argue that the yellowish colors that we see over here that indicate that we are dealing with a similarity, those are appropriate over here. And here. And here. But what I am worried about is this. I would hope that there is no similarity with regards to this gender direction when we're talking about doctors and nurses and physicians. Gender should not play a role there. However, we do see that there is this correlation. And I can argue it's not just due to coincidence. I have added some completely unrelated words here, and we indeed see a very dark color on this axis as well as this one. So the correlation, if you will, that we see here that seems to be embedded in the word embeddings, and that's not a good thing. As a final step, what I've now done is I have done the same exercise, not just using fast text, but also using the large English spacey model and the largest byte pair model I could find for the English language as well. For all of these models though, this correlation over here, it persists. It's there. But maybe we shouldn't be too surprised here. After all, let's say that Wikipedia was the webpage used to train these word embeddings. Well, if there's bias in the data, then the machine learning model is going to pick this up. Potentially, it's going to get amplified. So the question is maybe not, is there bias in my word embeddings? It is very likely that it's the case that there's bias in your word embedding. The next question might then be, well, what can we do about it? One thing that you can do is you can maybe consider not using word embeddings for certain applications. To me, resume ranking sounds like a pretty dangerous idea using this technology. Another thing that you can do is you can ask yourself the question, well, can we remove the bias? And this is something that I'm going to explore in the next video.